Okay, hey everybody, Dirk here. Welcome once again to the Dungeon Laboratory. Um, Wanted to kind of do an overview of this. This is pretty much a finished project here. I have space on the side here. I kind of raised this up with some plastic standoffs. I have room on this side here. I'm going to attempt to add an interrupter circuit at some point to this. I don't want to fiddle around with it too much because I only have one. I'm pretty sure one remaining MOSFET that I'm using, which is the IRF P250N. That works very well with the circuit. You could use 460s too. Not sure though. It seems that the 250s last at least for me. The circuit that I'm following uses 460s, and you can go ahead and use that if you want to. Or you can do 250s as well. It's quite all right. I thought I had used a some other circuit, but apparently not. I apparently used let's see if I can turn this off so it's not so bright. I used the circuit right here, which is the same as the magnetist is also using. I'm pretty sure you're going to be watching this, so I indeed used the exact same circuit that's posted right here. For this, I have 5 nanofarads on mine, but that's indeed using a 250 and not the 460. It could be the same. That's the value you'd have to kind of play around with to see what it is. I'm not 100% sure what that's there for, seeing that that's coming onto the gate and going on to the source. So I'm not sure what that's there for. It might be for back spikes coming from this from the coil itself. I'm not 100% sure what that's there for. I don't know everything about this circuit. I do know that it is very it can be unreliable and unstable when certain components or criteria is not met when it comes to building this thing. Yeah, as far as the wire gauge, 0.5 millimeter, I used 16 gauge wire, which is a 1.29 millimeter. So I use 16 gauge for all my coils. Let's see here, the 2.5 centimeter, 2.5 centimeter, and 2 centimeter. Both the actual secondary coil and the feedback on mine are 3 millimeter diameter, and I believe this one is 2.5. So I increased them just a little bit. That's about it. All the other components are pretty much the same. For the resistors, I do have the Zener diode on there as well. I also added a back-to-back Zener diode from gate to source on the MOSFET itself. So, in the thought of having some additional protection for the MOSFET. It's essentially this potentiometer here is going to set. It basically kind of sets the gate voltage, so you don't want to go too high with that. I'll try to demonstrate as best I can. It's good to have some meters over here, particularly this one. You want to pay attention to this one. When I get this running, you'll see what I mean. So, yeah. As far as the rest of the circuit is concerned, everything else is pretty much the same. I did change out my capacitor from a 47 to a 10. Just because the leads were longer on there. I would suggest not using an electrolytic here. Use a metal film or something if you can. It has to do with the high frequencies. They can blow up. I did have one blow up on me in the past with another type of circuit. So, yeah. And the voltage rating of mine is 350 volts. Obviously, you can see 8 to 30 volts. My circuit will not oscillate at 8 volts. No way. Minimum, I would say, for mine is maybe 20 volts. Or you can set it up to 30 volts, get it running, and then you can dial it back down. You can run it at like 15 volts maybe before the breakout disappears entirely. And that's what this is. The circuit diagram, unfortunately, doesn't exist anymore on the other website from another YouTuber, Tesla Unmea. His website doesn't exist anymore, so hopefully this is the best I can do. So I'll try to hold this steady here. So if anybody wanted to copy this down, they can give it a shot. It's, like I said, it's not an easy circuit to get going. But once you do, you know, try not to mess with anything. As soon as you get your potentiometer set, you basically want to set your potentiometer to where you want to set it at the minimum, so that, you know, the circuit oscillates and functions. But you don't. As soon as you have it set, I would probably suggest you can use a normal standard potentiometer like what I used. A trim pot would work a lot better. And once you have that sweet spot where the circuit, you know, oscillates every time it's turned on, put a little dab of glue or something on there. Don't mess with it. Just leave it alone. Don't touch it. It's fine where it's at. That's something you're going to have to play with. You'll know. It's really hard for me to explain this. It's because you basically you're going to want to turn. Gradually turning the potentiometer. Turn the light back on. I don't like having the lights not on here. Just grab potentiometer. Yeah. So you just, you know, you're gonna gradually, you know, turn it into where you see it actually comes on. You know, it's going to be very small increments of turning this until it oscillates. And once you get that point where you think, oh, okay, it's going to oscillate, if you back it, you know, going the opposite way, and when it stops, you know, you can kind of mess around in that little area that you have there, that little area. And then you'll kind of know where to set it at, you know, the minimum gate voltage to get it going, and leave it. You play with it around too much, you're going to kill the MOSFET. Guaranteed, it will blow. So that's very one critical thing on here is that potentiometer right there. Very critical. It doesn't matter if there's a Zener diode there. It doesn't matter if there's two back-to-back Zener diodes there. I've tried it. Doesn't really matter. It will kill your MOSFETs. This might help, you know, having this Zener here and having maybe another back-to-back on there. It'll help, but I don't know. I've probably killed at least 10 MOSFETs getting the circuit going. But hey, it works now, and that's basically what it is, you know. And this feedback coil here. Some people smush them together. Some people stretch them out. For me, having it stretched out works. It's another thing you have to kind of play with. There isn't a guidebook on here. There's like 1,000 different ways of going about doing this. This is a very simple circuit. There's more complicated circuits for high frequency Class E style coil. You know, this is a kind of a crude Armstrong type oscillator where you have a primary and a tickler coil. You know, going back to the transistor or tube or something like that. This is kind of in that range, right? Right. So I basically have my potentiometer set perfectly. I will never touch it again. That's it. So I'm going to turn this on. Actually, it's already on. I'm going to get my my fan going here in the back. Is correct. So I got that going because the circuit does get hot. I'm just going to apply some voltage. No, did you see it? See it go up like that, and go back down, and go back up, and go back down. That's what you want to. Having it, you know, an amp meter. I don't care if it's analog or digital. I never tried it with the digital one, but that tells me right there that I have my potentiometer set where it needs to be, because it's jumping from it should be 0 amps directly up to 2, meaning the circuit is in oscillation, but it's not tuned yet. That's where that comes into play. So I'll sit you guys down here. Need to get a better tripod. This is probably going to be kind of a longish video, and I'm going to be doing a lot of chatting, but it seems that some people, you know, are having trouble getting this to work, and I'm hoping I explain as much as I can and what I know. And yeah, I don't know everything. I don't claim to know everything, but you know, I know good deal stuff. Anyway. We'll do like 30 volts or something. And I need found my chicken stick. Go. It is on. Working, doing what it's doing. And yeah, it's so bright because that tip is literally melting on that nail that I have on there. It is pulling a lot of power, between 5 and 6 amps. And that's why you need a fan with a huge heatsink on there. It's a very inefficient circuit, but it does work. And then, so as I said, once you get the going, you can gradually turn it down. It's still going. We're at about 15 volts. 15 volts. Drag it down a little bit more. Oh, and there it goes. It's out. It was still oscillating, but it was out. So yeah, that 8 to 30 volts, I don't know. I guess it might depend on how you built the circuit, or hell, I don't know. You know, there's different ways of going about doing it. This is the way that I built it. It seems to work. There's no... I'm waiting for the rest of the voltage to kind of bleed off here. Even turn that off. The way I built this, essentially, because you're going to use one of these big variable multi-gang capacitors. You know, I'll give you 2 gang, 3 gang, doesn't matter. I tried using a fixed capacitor. This is exactly the value that I need right here, which is 110 roughly picofarads to put this in resonance. It won't work. I don't know why it won't work. I tried it. I tried it on there. I don't know. It won't work. I tried various ways of doing it. It needs this variable capacitor, because even if I have it right here, this is exactly where it is. Roughly 110 picofarads. That's where it needs to be to achieve resonance. Yeah, basically, more or less. But if I turn it back on, it won't oscillate. It won't do anything. Basically, I'll have to move this back up into a fully closed position, or even a little bit less, and it will start to work. And then you have to decrease the capacitance until you get that sweet spot. It will break out at a certain point, but it's going to be very minimal. And then if you keep, decreasing that capacitance, it's kind of hard to say. It's almost like it's oscillating at a different frequency, like at a higher harmonic or something like that. I might be talking out of my ass. I don't know. I don't understand all that type of science that goes along with this, and all that good shit. I'm an experimenter, and I can build circuits, and I can kind of figure out how things work. As far as the maths are concerned, I get lost in that, and theory, I know a good deal, but not a whole lot. But that seems to me that as I'm tuning this, it'll break out, but it's not the correct frequency. And then as I'm gating or going further down in capacitance, then it almost kickstarts into that big flame like what you see there, and that's basically the resonance, because you can hear noises and whatnot. It'll be kind of like a crackling kind of sound, and typically you won't hear that with the circuit. There could be 2 reasons why it's crackling. Number one is because there is high voltages on this capacitor, right? And that crackling is most likely due to arcing between the plates. that are on here. And that's not good. You don't want that. You basically want it to where you don't hear anything. You'll barely be able to hear anything from this flame because it is such a high frequency. It's basically like a silent flame, unless you're burning something or melting something. You know, who knows what. Yeah, it should be quiet. Shouldn't hear a damn thing. Yeah, that's working quite well there. Right. The way I constructed this, Tesla Explorer build his pretty much the same way. He helped me get mine going to where it is now, and the style of building is basically from his side. So the drain of the MOSFET is directly tied to this heatsink, right? So any other connections to drain go directly to this heatsink. So this is another area that you do not want to touch. You don't want to touch this. You don't want to touch that or anything metal around here. Even this, even though it's painted, you'll get RF burn off that. No go. So don't touch any of it. Yeah, as you can see, my it's the first coil, L1, tied here. L2, feedback, tied here. All right, both those are tied there. And the drain of the MOSFET is also tied directly to this bad boy. That's why I chose this fan here, because it's all plastic. It's isolated from, yeah, basically from the heatsink. So yeah, so that it will work. Basically have all my stuff here. I guess I can show you a little bit what it's looking like. I had a lot of these. These had different components in there before with banana jacks, so I went ahead and just used these banana jacks again. Worked very well. I'll just keep that cooled off. So this thing does get hot, so as you can clearly tell. What else? Yeah, the way this is constructed here, you can see there's this big green thing right here. And what is that? Well, this is kind of a cruder version of that. But it's, yeah, my camera has terrible zoom, I apologize. But it's basically, you know, a connector block. You know, you can get these off of circuit boards or what have you. You know, I had a bunch of these laying about. I basically just kind of glued this together with a piece of Perspex. It doesn't look great, but it works. So basically, one end is for your MOSFET. Your MOSFET will connect here. On this side, we'll have your potentiometer. Yeah. Kind of, yeah. Crudely doing it. Yeah, but there's that. I don't have a... Oh, actually, I do. These are dead MOSFETs anyway. So it'll kind of just be like that, you know. On there. That'll go to your heatsink, and then you basically... The legs that are on these connector blocks, you build your components right on top of this. Almost like a dead bug style of doing it. And it's very compact, very neat. And this is a RF circuit, RF power circuit. You don't really want a whole lot of long leads on there. You know, obviously, your feedback coil. I'm pretty sure this is like a choke coil, you know, like an inductor. And, you know, these coils are obviously going to be long, because that's just how it goes. The lead length on this could be better, but as I said, I wanted to try to fix capacitor. That would have been even better. You know, being an RF circuit, you know, long leads and whatnot, it's stray inductance, stray capacitance. You don't really want that for the circuit. That could be another problem if you're, you know, building this. You know, even this might be too long, but you know, it seems to work. I haven't had any problems with it. It works fantastic. Still does. Yeah, you know, minimizing your lead length, you know, how spread out the component is, everything's kind of smashed together, compact. I made this as compact as I can. It's very heavy, having this and this on here, but they kind of, there's a good counterbalance, because that's a very heavy, old variable capacitor, and that's a really big, chunky heatsink that's right there. And it all worked out. Kind of built it on this board right there, and everything works. You know, lots of banana jacks and whatnot. This might not be the best idea, right? Right. Almost 20 minutes. Didn't even realize this black bit here is plastic, and considering how much power is going into here, that could very well melt. So I might have to replace that with something else. I do realize I have one on the back as well for the AC power that's coming in, but that's not drawing near as enough power as this monster is right here. So yeah, it's basically the best I could really explain how this is built and how this goes, and the troubles that you can have with this, what you could do to improve on it. Another thing is it could be the capacitance that's up here. I do have this here, and even this bit of metal here is capacitance. This is added capacitance. It might throw the frequency out a bit, but then again, you have a variable capacitor to tune your circuit, so it's not that bad. I would suggest putting something on here, on even this thick. This is a 16 gauge wire essentially, and that will it'll melt. It'll be destroyed because it's very hot arc coming out of that, as you can clearly see. So I'll have to tie this little bit of a video onto the last one. I hope this doesn't bore everybody to death, but I was just kind of hoping this helps a lot of people in getting their things built if they are interested in building something like this. I know the magnetist is trying to get his more compacting going, and I hope you don't pop any more MOSFETs, bud. it eats them. It'll eat MOSFETs. Not an easy circuit to go about doing. This is kind of in the lines of a Slayer exciter. In a sense, it's a very inefficient circuit. It's nothing fantastic. You're having a few transistors and or more in parallel, powering up a circuit. Yeah. So there you go. Hope that helps. Well, anyway, thanks for stopping by. We'll talk to you guys later. Cheers.